Today's vintage keyboard is an IBM type Model M manufactured by Unicomp sometime in the early 1990s. There'll be much clicking and clacking. Good morning. I haven't worked in Windows in quite a long time. Usually I'm a Linux person. To install software on Linux is extremely easy, and looking over Windows, I see Windows has taken some of those ideas. If we use the Silverfrost compiler, there's upsides and downsides to it. The upside is it's free, of course. Another upside is it comes with an integrated development environment. The error messages, in particular, are pretty good in Silverfrost. The one huge downside to it, though, is that 5-second delay before it will begin executing your programs. This was annoying to me. I went off and installed something called Strawberry Pearl, which I have a video up on my YouTube channel about. This installs the GNU Fortran compiler, and there are ups and downs to it also. The ups, it's free. Secondly, there is no 5-second delay between starting your program run and actually seeing anything happen. There are downsides. By itself, it's a command line compiler, so no GUI, although we could do something about that if we were interested in it. So what I'm going to do is I'm going to use GNU Fortran on this fresh install of Windows to have my bit of fun with Fortran, like we said we were going to. On the command line interface, I type CMD. I have two monitors, so pardon me while I move this over. I've changed the defaults on this to be nicer looking to my eye and also have a larger font. We're going to be doing fun with Fortran today, so I want to organize my files. I could use the mouse and the file manager to create a new folder, or I could just do it from the command line. Since I'm feeling all old school today, we'll do it that way. So I now have a directory that didn't used to be there. Fun with Fortran. All of my programs that I write today are going to go into that folder or directory if you prefer. From the command line, I can change into that directory. There are no files at all in there. There are lots of different text editors you could get. I'm just going to be intensely lazy and use Notepad. I'm going to say Notepad hello.f90. Over on the other screen, it's asking me, cannot find hello.f90. Do you want to create a new file? I'm going to click on yes, and I'm going to drag that over to this screen. Obviously, I'm going to do the standard Hello World program. So I'm going to print Hello World out to the default device and then say End Program. Save is Control S. and I'll just leave the edit window where it's at. So there is a file called Hello World, which was just now created. To compile it using the GNU command line compiler, here's what I say. I say G Fortran, and then the name of my program source file. It didn't issue any error message, which is good. And if I look at my files that I have left sitting around now, not only do I have a hello.f90, I've got this file called a.exe sitting around as well. I can run it by typing its name, A, and hitting enter. And it says, hello world. You'll notice the utter lack of a 5-second delay. So this is worthwhile in terms of losing the GUI, as long as things are not going to get too complicated, which hopefully they won't. For demonstration purposes today, I'm just going to keep modifying this file, hello.f90. The first thing I'll do is I'll take out the print hello world statement, and then we'll put some other stuff in as well. So I'll go down here to where I can see my editor window and click on it. I'll go up here and take out the hello world. I'm going to be doing some stuff with variables in a while, but for right this minute, I'm not going to. I just want to do some seemingly ridiculous things. I'm going to print out 3 divided by 2, which we all know to be 1.5. I'm going to print out 9 over 2, which is 4.5. And I'm going to print out 1 divided by 3, which is 0. And then an unending string of 3s. And that's all I'm going to do in my program. So I expect to see 1.5, 4.5, and 0.3 repeating. Control S should save it. I'm using the up arrow key on the cursor pad to give me my compile statement back again. Oh, this thing doesn't remember. When I execute my program, I get 1 and 4 and 0. I was expecting to get 1.5 and 4.5 and the 0. When the computer sees that 3 divided by 2, it has no reason to think that it's any particular data type. What has happened here is it's interpreting those 3s and 2s and 9 and 2s and 1 and 3s as integers. And when you do integer arithmetic, the result has to be an integer. So the part after the decimal point does not actually occur. I've altered my program by saying instead of just 3 and 2 and so on, I say 3.0 and 2.0. This tells the compiler in no uncertain terms, do not assume those numbers are integers, they are floating point numbers. I saved it. I recompiled it and rerun it. I get 1.5, 4.5, and then 0 point, several 3s, and then a 4 and a 3. If you remember our discussion of floating point arithmetic, you know what's happened here. It calculated the value of 1 divided by 3 in binary to as many bits as it had available. Depending on whether the thing ended in a 1 or a 0, it could have got rounded down or rounded up. In this case, it got rounded up slightly. We should not be too disturbed by that 4. An interesting comment on the Silvercross compiler, whoever packaged the defaults up was very aware of this. So instead of printing all of the digits that are in the actual variable, if you do this on Silvercross, I think it only prints the first 6 digits. Which will keep you from seeing the unusual looking 4. On one level, this is kind of nice. The compiler writer is trying to make the user feel better about things. On another level, this isn't nice at all. The truth of the matter has been hidden from you. So be aware of this. Different compilers default to different behaviors. Fortran was designed for scientific and engineering calculations. It has a very large number of built-in functions, including the ones that you would expect. exp is exponential, sin is sine, taking the input to be in radians, log is a logarithm function. I'm not going to say whether it's base 10 or some other base because we'll find out in a minute. Fortran is a strongly typed language. It expects certain things of inputs and outputs out of functions, and I've made a deliberate mistake here. So Control S. I'll go over here and see about compiling my program. It doesn't like it one bit. It draws that little 1 underneath the exponential. It says the input argument, the x argument in e to the x, must be real or complex. Pretend you don't see the complex bit. Same story on the sine, the same story on the logarithm. The thing about it is, those functions expect to receive a floating point number, and because of what we were talking about a little while ago, this 1 that I'm feeding into sine and exponential, and the 2 that I'm feeding into the logarithm are being treated as integers, and the compiler is saying, I'm not accepting that. So I've edited my program to change those integers into, no doubt about it, floating point values. Control S to save. I will run up here to my compile window. And recompile. It's still complaining about it. I did change this. Maybe I forgot to save it. Let's try that again. Yes, I had just forgotten to save my changes. And if you check it with a calculator or some such thing, e to the 1 power, which is e, is about 2.71828 some odd. The sine of 1 radian is about 0.84147, and the logarithm of 2 is 0.6931 some odd. That would be the natural log. So in this computer, on this compiler with this language, log means natural log. If I'm going to do any actual calculations, I'm going to need to have some variables. So I'm thinking of doing Newton's method. I'm going to have x, which is an approximation to the solution of some problem, f of x equals 0. I'm also going to need the function value and the derivative value that go with the given x number. Also, I'll probably be doing this by going around in a loop several times, so I'll need some sort of integer or counter of some type to keep track of how many times I've done all this. I'm going to be doing these repetitive calculations. So to get started, I'll think about going around in a loop 10 times. This will be executed for each value of I from 1 to 10 inclusive, and at the moment I'm not doing anything except printing the I out. I kind of like to do things sort of incrementally, especially if I'm working in a language that I don't know much about. So I'm just going to put a little bit in, and then we'll put another little bit in, and pretty soon we'll have a calculation. So go back to my command window here. I'll recompile my program. Didn't catch any syntax errors or context errors or anything like that. So I've saved my file now. I'll go to my command window and recompile it. It didn't see anything objectionable on a syntax level, and it prints out 1 through 10 just like we think it should. So I'm going to be looking for a 0 of the function f of x equals x squared minus 3. The f variable in this program contains the function value that goes with whatever the current x is, and the f prime variable, the derivative value. We do Newton's method by saying x equals x minus the function value divided by the derivative value. I've altered my print statement so that it's printing out I and x, so I know which step of the calculation I've just completed, and I'll print out what I've got at that current step of the calculation. Saved it. Compile it, and it doesn't like that. Now, I could claim that this was a deliberate mistake to point out what happens. The fact of the matter is, I just made a typo. I typed f pine instead of f prime. The compiler is not under any great compulsion to tell me, but this one is nice enough. It noticed that there was a variable named f prime, so maybe that's what I meant. Right there. F prime. Then I'll save my file. Try to recompile it. And this time, there's no problem. Now, that doesn't mean I've typed all of my stuff logically correctly. It could be someplace I meant to add and I subtracted, or subtracted when I meant to add. The compiler can't catch that kind of thing, but it can catch syntax errors and such stuff. I'll run my program, and I get these numbers. Looking at it, it looks like it's not changing much anymore after a while. So if I want a bit of a refinement, I can say this. Right before I do a new calculation, I save the value of the current x into a variable called xold, which you'll notice I had to put on my list of real variables that I'm declaring up at the top. Then I do my calculation. I print out the index and the current x value, and then I paranoidly check for something. It's extremely unlikely in the actual real numbers that you'll ever have the x and the xold being exactly the same number, but we're doing computer arithmetic, and remember, there's only so many of those floating point numbers to go around. So I'm going to check if, unlikely though it may seem, the floating point value in x is exactly equal to that in xold, then I'm going to print out an error message. It's not really an error, I guess. I'm going to print out an informative message to the user, and then I'm going to issue the stop command, which does exactly what you think it does. It halts program execution and hands control back to the operating system. Of course, you have to have an end if when you have an if. After that, if I haven't stopped, I'll go around and do more iterations until either I've done all 10 of them or this if-then clause has been activated. Then, end program, that's the end of that. Control S in this editor saves it. See if we made any syntax errors. Doesn't look like it. Then I'm going to run my program again. Bailing. After we did 5 steps of this, during step number 6, the new estimate is the same as the old one, so there is no point in continuing to do this. If there's any mystery about why this has happened, go back and look over your notes for that floating point arithmetic thing. It is sort of in our faces now. Since we're just having fun here today, I think I'm going to ramble around and talk a little bit about logic.
Logical.
I'm going to introduce logical variables, S, T, Q, and R. Logical variables take on only 2 values, either T for true or F for false. In this first statement, S is going to be the logical statement 3 is bigger than 4, which is false. So I'm going to say S equals 3 bigger than 4, and then I'm going to print out the S. I expect to see the word false or the letter F or some such thing. Then I'm going to let T be the logical statement 5 is less than 6 and print T out. I expect to see true or a T or some such thing. Lots of times people will put these statements like 3 bigger than 4 and 5 less than 6 inside of parentheses to try to minimize the confusion. Q is going to be the logical statement that T and S, if T and S were both true, that would be a true value. If even one of them is false, it'll be false. And since 3 bigger than 4 is false, I expect to see a F for the Q. R will be T or S. That's going to be true if either one of the T or S is true or both of them. But if both are false, it will evaluate to false. Save the file, recompile it, run it, and we see what we expected to see. False, true, false, true. This is a modern notation. Other times you'll see in older programs a different kind of notation, which basically means the same thing. You'll see .gt dot, which is short for greater than, .lt dot, short for less than. There's also GE greater than or equal to, and LE less than or equal to. The compiler accepts either notation and, of course, produces the same results. There is a logical negation operator. .not dot Q is true when Q is false and false when Q is true. So this last thing that I print is not Q. S is false, T was true, Q was T and S, which is false, and then I'm printing out the negation of Q. Save my program. Run it, and at the end I get the T value like I'm expecting to. You can obviously make arbitrarily complicated combinations of these kind of things. It's moments like this that you actually do appreciate a good IDE. There are so many parentheses and stuff here, it would be easy to get a mismatch. The value that I'm going to print out is the negation of something. It's the negation of this statement. So I'm going to figure out whether or not at least one of the two, or this statement is true, or that statement is true. If I get a true value when I take the negation, I'll get a false value. And if this evaluates as false, then the negation will evaluate as true. Of course, this is assuming that this compiles at all, and I haven't made any typos with respect to all of the different parentheses. It might have been better to break this up into chunks, but we'll see. It's a miracle. The number of parentheses matches up. And when the dust finally settles, the value of that big, complicated expression is T. One minor point you have to worry about is almost everything works the same with logical as with other things in terms of constructing if-then-else statements, that sort of thing. But if you want to compare two variables and see if they have the same truth or false value, at least on a lot of compilers, the equal won't work. I'm not sure about this particular version of Fortran, so let's go have a look. If you're not sure if your particular compiler supports a particular syntax or not, One way to do it is to dig out all the manual pages, dig out all the documentation, read hundreds and thousands of words, and then find out for sure. Or you could do an experiment, which is what we're going to do. Full acknowledgement. The compiler may choke on this. Let's see. If statement T equal statement S, then else. So what I'm really interested in here is seeing if the compiler will understand what I mean by that. It either will or it won't, and if it won't, I'll show you the older fashioned notation here. So Control S to save my file. I'll see if I can compile it. And no, it does not like that one bit. Logicals must be compared with .eqv. So number one, the compiler won't accept that notation. On the other hand, it was nice enough to tell me what I'm supposed to use. I'm supposed to use .eqv . So let's fix that up. And according to the message sent to us by the compiler, it ought to believe that now. Now it's not complaining. And I run it, and it says that second choice, goodbye. We're just having a little fun with Fortran right now. And saying goodbye seems to be a pretty good way of ending this particular video. So what we're going to do is we'll have another one pretty soon where we'll have even more fun in the sense of functions and stuff. In the meantime, I hope everybody has a good day, and I'll talk to you again soon.